Okay, this is the second of two videos. The first one was about ratios, and just to highlight that, okay, go back on this. A ratio is just a comparison of two numbers, and if we have two numbers that we're comparing, we can write them as a to b with a colon, or a to b as a fraction. Okay, and we're going to stick with the fraction part because we know how to solve stuff that deals with fractions. A proportion, contrasting that, is an equation. That means there's an equal sign involved. Okay, an equation has an equal sign. That's what it says, equa there, and it says that two ratios are equal. So maybe I say the ratio of A to B is equal to the ratio of C to D. Maybe that's what it looks like at first. Since I printed it off, it already did the animation here for me. Okay, so notice I've had a ratio on the left and I have a ratio on the right, and I'm saying that this ratio is equal to that ratio. That, by definition, that's what a proportion is. Okay, and the nice thing is, you guys have probably already learned this in your algebra classes before. If I have two fractions and they're equal to each other, I can cross multiply in order to solve for them. So I can take B times C, and that's what these gray lines are here for because I printed it off. Okay, B times C is equal to, cross multiply over here, A times D. Looky there, no more fractions. We're going to find that to be very convenient because that's going to help us to get to a point where we can solve for x easily, right? Solve for a missing dimension. That's the point. So, next slide I have is just a few examples, so be prepared to follow along. Remember that you can pause it because it's a video. You can pause it anytime you need to catch back up with the writing. So, first example, let's say 5 over y is equal to 45 over 63. The first step that we probably want to go through is take the 5 times the 63 is 315. And on the other side is 45 times a y. And if 45 y's are equal to 315, then I divide both sides by 45 and I get 7 for y. 5/7 is the same thing as 45 over 63. Now, of course, I probably could have figured that out probably pretty quickly and easily if I would have just done this. 45 over 63 on my calculator. I hit enter and it tells me 5/7. Oh, huh. So sometimes, not always, but sometimes you might just look and see if I've got just numbers, I've got no letters, in other words, over here, maybe just see if that reduces. Maybe that makes the problem pretty easy, right? Just a thought. Down here, example B. On this one, I've got a negative, so when I take a negative 1 times a positive 2x, a negative times a positive would give me a negative. Be careful with that. So I have negative 1 times a positive 2x is negative 2x. And on the other side, I have 3 times 4, which is 12. And if x times a negative 2 is equal to 12, I divide both sides by negative 2. X would be negative 6. Right? So negative 1 over 4 is equal to 3 over 2 times negative 6. That's what I'm saying. Now, how that gets tougher is whenever I start throwing stuff like this. Now, this is actually a distributive property problem, so keep that in mind. This is going to be distributive property because I'm not taking the 2 times the x. I'm not taking the 2 times the 3 when I do cross multiplication. I'm taking 2 times the whole thing. Okay? So, on one side, I will have the 2 times the x plus 3. The other side, I will have the 7 times the 12. And that gives me 84. You see the distributive properties show up, right? So my next step then, pretty simple. Go ahead and distribute the 2. 2x plus 6 is equal to 84. Subtract the 6 from both sides. So 2x is equal to 78. Divide out the 2. X is equal to 39. I had to think about that for a second. So pretty straightforward. Just keep in mind, if you have plus signs showing up inside of your fractions, that's going to be a distributive property problem. Okay? Not tough, just one extra step. Last one. This one doesn't look too bad until you actually go to cross multiply it. Okay? So let's do this first. Notice, by the way, if I wanted to, that the 40 and the 5 would reduce. Okay? That would become an 8 over 1. And if I wanted to, the 2 and the 16 would reduce. That would become a 1 over 8, right? But let's just pretend that I didn't know anything about it, so I'm just going to go ahead and do all the straight multiplication. On one side, I'm going to have 40 times 16. That's going to be 640. On the other side, I have 5x times 2x. And so here's where the math comes in. 5x times 2x. Well, 5 times 2 is 10, and x times x is x squared. Now we're dealing with squares. Uh-oh. Well, how do I solve for a square? I think the easiest route to take in this situation is just to simply divide out the 10 first. Okay? If I divide both sides by 10, then I get 64 is equal to x squared. And then I need to square root both sides. And remember, if you square root both sides, you have to put in a plus or a minus. So it's plus or minus the square root of 64. Well, the square root of 64 is just 8. So x can be either positive or negative 8. That's the easiest approach to take to solve that kind of a problem. Just remember it. This is the big rule right there. The plus or minus is the number one most missed step on this type of a problem. So, if that makes sense, then I'd say you're ready to start in on the homework, because most of the homework that you see will look like this stuff that you see on this page. Okay? Later at the end, you'll get a chance to do a couple of word problems that deal with ratios and proportions and setting things equal to each other, but they're not going to be too difficult right now. The hardest problems will be the ones involving the x squareds. So know how to solve those, and if you can't solve those, then come ask for help.